Okay, so yeah, let's go ahead and look at some problems from section 3.2 and 3.3, and that should finish out the review. And I'll try to find some that have uh, a wide variety of examples. Okay, so let me take a look and say maybe, hmm, so let's say maybe we can look at this one. Okay, so question um, are let's say f of x equals to 2x squared plus x minus 7 and g of x equal to x squared, the same order. So basically what this is asking is f big theta of g, and if it is, then it's the same order. So let's say that, okay, um, maybe we want to find a big O estimate on this thing here. So we'll say, so first let's focus on f and find a big O estimate on that. So by the way, they are the same order by a theorem in that section with textbook, but we're just going to show it. So let's look at the absolute value of this. Now, in order to make sure that this is positive, one thing that we can do is we can just make a rough estimate and say, okay, now I know that this would be positive. We can drop the absolute values if x is greater than 7. Because then you have a 7 minus a 7, that's going to be a positive number, that's going to be positive, so we just drop the absolute values. Okay. Now, since this is positive and we're subtracting off a number there, right? Then we can just drop that and say that this is less than or equal. It's actually going to be strictly less than. Right? Like this is surely bigger than that because you're just subtracting off. Right? Now here, and again, we have to make sure that x is greater than 7. And then this is less than or equal to 2x squared plus x squared. Again, x is greater than 7. So when x is greater than 7, x squared is greater than x. Okay, so now we just combine like terms, and we get 3x squared. Okay. So then here, this is truly equal to 3 times the x value of x squared. And again, we're still assuming that x is greater than 7. So then we're done. So we're not done with the question, but we've shown that f is big O of g of x. So we take c is equal to 3 and k is equal to 7. We have shown f of x is big O of g. Okay, so let's just make note of that then. So okay, so f of x is big O G of x. All right, so now we need to show that f is big omega of G of x. All right, so do this again with absolute values. So the same trick applies here. We can drop the absolute values. Like that when x is greater than 7. Okay. So then if x is greater than 7, then this is a positive number right here. So then this is going to be greater than or equal to 2x squared minus 7. Right, if we just take away the x, that's true since it's a positive number, right? And then actually, if x is greater than 7, right, if x is like 8 or 9 or something like this, then subtracting off x is going to be smaller. Right? But if we're subtracting off x, then that's surely going to be bigger than if we subtract off x squared. Again, we're assuming x is greater than 7. So now we just combine my terms, and we just get x squared. That's just equal to 1 times the absolute value of x squared. And again, we're assuming, again, that x is greater than 7. Okay. So then, if we take c is equal to 1, k is equal to 7, we have shown f of x is big omega of g of x. Okay, so that's what we show. Okay, so then we're done. Now we've answered the question. So with all that work, so after you did that work, you say something makes sense. F of x is big O G of x, and is big omega G of x. F of x is order G of x. Okay. And they have the same order. Okay. Okay, so one problem. Let's look at another one. Should I do another big O, big omega, big theta on these functions, or should I move to the complexity of algorithms where we try to measure the complexity of the.
Will you do one more of these?
Sure, one more.
Okay. Let me pick one. Okay. So, a good one. Problem. Show. X cubed is not big O of x squared plus 2x, 4x plus 17. X squared plus 4x plus 17. And we did one of these. We did a similar one to this in class. So solution. So if you're going to show this, you're going to prove this. You assume by contradiction to be proved it. If you're going to show something is not big O with something else, then you typically will do this by contradiction. So let's just say by way of contradiction. Suppose x cubed is big O of that polynomial. Okay. So under this assumption, we have the witnesses C and K that bound x cubed in absolute value from above by a constant multiple of this polynomial. So then, by definition, there are constants C and K, so that the absolute value of x cubed is at most C times the absolute value of this polynomial, x squared plus 4x plus 17. And this holds for all x greater than k. Okay. All right. So, so maybe I can say like for large enough x, maybe let's say for large x greater than k, or maybe for positive x greater than k, we can drop the absolute values. So since this absolute value inequality holds for all x greater than k, eventually there's going to be positive x greater than k, right? Off to infinity. So for positive x greater than k, we just drop the absolute values because that'll be positive and that'll be positive. Okay. So, and again, this is for positive x greater than k. But then we can replace that and that, and we'll just write it down. Like that for x greater than root 17 and x greater than k. Do you see why I can write this inequality from here to there?
Yeah.
Right, because if x is greater than root 17 and greater than k, then x squared is greater than 17 and x squared is greater than x. So I can just say that this is less than or equal to this. So now I can combine my terms. And what do I get? 5, 6, so 6x squared. And again, got to make sure that you inform the reader x greater than root 17 and x greater than k. Okay. So we're trying to get a contradiction and we're about to. So if we divide both sides by x squared, we get x is less than or equal to 6c. And again, for all x greater than root 17 and x greater than k. Any x that satisfies those, this must be satisfied. So I just said the contradiction. For any x that's bigger than k and greater than 17, this must be satisfied. Okay. So, so maybe we can say, yeah, so if x is greater than 6 times c, and x is greater than root 17, and x is greater than k, then x is not less than or equal to 60. A contradiction. Because this is supposed to hold for all x greater than root 17 and greater than k, right? For every single x that has to hold, right? Because this inequality has to hold for all x. So if x happens to also be greater than 6k, I mean 6c, because c is a constant, right? Then if x is greater than that, then this inequality doesn't hold. That's a contradiction. And I need them. Okay. Okay. And I think if you look at our previous lectures on this topic, I think you'll be good for the exam because the questions are going to be so similar to the ones that I've done in class that you should be able to piece together what's missing. Okay, so okay. So let's just write down. So input, say A1 through AN, which are positive real numbers. Okay, and then we just have a description of the algorithm. It doesn't say the name of what it does or what its name is and what it does. It just gives a description. So M is equal to 0, and then it says for I equal to 1 to N, for J equal I plus 1 to N, M is equal to the max of A, I, A, J, comma, M. Okay, so this is the description. It's an algorithm. I wonder if we can figure out what this is trying to do. Oh, it's looking at the maximum product of two numbers in the list. Do you see that? Someone say.
Can you explain a little further on that?
Can I explain what?
Can you explain a little further on how it's a product, the max product?
Okay, yeah. So we have this like list of numbers, right? So I say like, so I'll just start a small list: A1, A2, A3, A4, right? So now for I is equal 1 to N, so we set I is equal to 1. Well, originally M is just going to be equal to 0. So then we set I is equal to 1, and then we enter into this for loop here. And now J goes from 2 to 4. So then J is equal to 2, and then we're going to say M is equal to the max of A1 times A2, comma, M. So A1, A2, so this is like 2, 3, 1, and 5. So then it'd be 2 times 3, so the max of 6 and 0 is 6. Okay? But then J increments to 3, and then M is going to be equal to the max of A1 times A3, comma M. The M is now 6. So A1 times A3 is 2, so 2 comma, so this will still be 6. And then J increments to 4, and then M is equal to the max of A1 times A4, M is still 6. So A1 times A4 is 10. So the max of 10 and 6 is 10. And then we've reached N, and now we increment I. So then this would be like one iteration of it. And then I is now is equal to 2. So now it's going to be A2 times A3, A2 times A4. The max of those getting updated each time. This is going to find the maximum product of two numbers in the list. Did that help at all?
Yes, it did.
That's not J starts at 3, right? And then that means that. So okay. Okay, so what is the question asked? So, problem. Give a big O estimate for the number of operations and they define in this problem operations to be comparisons and multiplications. Where operations are Boolean comparisons and multiplications. Very good at that. All right, so give a big O estimate for the number of operations with operations or comparisons and multiplications. Okay, so let's see if we can figure this out. So what happens here is that, okay, when I is equal to 1, we go inside the for loop here. So then we have J is equal to I plus 1 to N. And then the max operation here, we're going to have to multiply two numbers, right? So we're going to, so it's going to be, so for example, J is 2 now, and then we do one multiplication there. So that's a comparison. So this is for AI times AJ. So I mean, that's a multiplication, so that's one thing we're keeping track of. And then once we do that multiplication, then we have to check to see if J is greater than N, right? So plus 1 there, and that's asking is J greater than N, that Boolean comparison. And then still for I is equal to 1, we increment J to be 3, and we're going to have plus 1 again, plus 1 again. So for each of the J's, we're going to have 2 operations that we're trying to keep track of. So we're going to have a total, when I is equal to 1, we're going to have 2 times n minus 1 operations. So if we're starting at 1, right? So then j goes from 2 to n, which is n minus 1. And that's for that for loop there. And then when we exit out, we need to see if I is greater than n, right? After we've done this for loop, we check to see if I is greater than n. So we're going to have a plus 1. That's another Boolean comparison. Okay. So what about when I is equal to 2? Well, now we're starting at j is equal to 3 to n, right? So this is like saying 2n minus 2. Boolean checks on j, and together with those multiplications, ai times aj. And then when we exit out of that for loop here, where you have to compare I against n again, so we get a plus 1. Okay. And we do this for each of those I, right? So it looks like it's going to be the sum from I is equal 1 to n of 2 times n minus I plus 1. Right, like that plus keep on going until we get to there's a problem with this algorithm. Does anyone see it? There is a problem with this algorithm. I goes all the way up to n. J starts at I plus 1 to n. So that's maybe they weren't trying to like actually have this be a working algorithm in the textbook, but this would be a problem. This really needs to say n minus 1. Because otherwise this for loop would be in, so like if I made it all the way to n, right, this for loop would start at n plus 1. You can't do that there. There is no n plus 1 element in there. So it needs to only go up to n minus 1. So that means that our sum is only going to go up to n minus 1. So for each of these I, we have 2 n minus I comparisons here, and then comparisons and multiplications, and then we have plus 1 to make sure that I isn't bigger than n minus 1. So let's look at this. So there are exactly this many operations. Okay. I've seen this formula before. Something very similar to this appears in another lecture of mine. And I'm pretty sure that this equals then minus 1 squared. So let me just make sure. So if n is equal to 4, I'm just like validating this guess of mine. I'm pretty sure that's it. So then this sum would be I is equal 1 to 3 of 2 times n minus I plus 1, which is equal to, so, oh, this is a 4. So 4 minus 1, 3 times 2 is 6, plus 1, 7. And then I goes to 2, so 4 minus 2 is 2, so 2 times 2 is 4, plus 1 is 5, plus, and then I is 3, 2 times 1 plus, so this would be a 3 as well. Okay, so it's 8 plus 7. Oh, it's this. This is the formula. And you can see how I figured that out in the other lecture that I posted on this topic. Basically, you would find the formula for number of operations, and then you would just plug in values for n, like starting at 2, 3, 4, and 5, and evaluating it. And you would see that the sum is always going to be n squared minus 1. So like n is 4 here, so n squared is 16, minus 1 is 15. So this is the number of operations. So the algorithm is big O of n squared. Because that function right there is big O of n squared. Okay. Okay. Yeah, that seems very similar to a type of problem that I would get on the exam. Okay. And I really think that's it. If you watch the previous test review and this test review, and you watch the YouTube lectures on these topics, I'm gonna put problems that are very similar to the ones that I've already recorded. So, do you have any questions?
Professor,
Yes.
is the format going to be the same where we complete it and we turn it on Monday at 5 o'clock exactly?
Yeah, just Monday whenever you get a chance to send it to me.
Oh, okay. Thank you.
It'll be the same format as before.
Okay.
This time, however, I'm going to ask that you submit it on Blackboard via Blackboard messages to me.
When is it available?
The exam will be available tomorrow afternoon,
Okay,
and you'll
Thank you.
have like 4 hours or something to take it, and then you just
okay,
send it to me via Blackboard messages on Monday.
okay.
Okay. Thank you.
Okay. Well, I guess that,
Professor,
yes.
how about the homework 5? Is it due today or tomorrow?
Homework 5. Oh, let me make sure it didn't. Homework 5 is due. It's not due until the 28th, I'm pretty sure. Let me just fix that real fast. Yeah, the 28th. Okay, so yeah, homework 5 is up and it's due on the 28th. Okay, so
Thank you.
yeah, just be looking forward to the exam posting on Thursday afternoon.
Professor, you said it's due on 11/12/2020?
The exam?
No, the homework 5.
Homework 5 is due on the 28th.
Oh, okay. It just stands.
Okay, well, everyone stay safe and good luck on the exam. Don't stress about it too much. Just watch the videos, have your definitions next to you, and you should all be okay.
Thank you so much.
Thank you very much.
Have a good day.